Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve and graph compound inequalities with the conjunction AND. So when we're solving and graphing compound inequalities, there's kind of two different ways we can go and do this. And I'm going to show the first way in kind of one of the simple steps. And then actually I'll do the top two in one way. And then the other way I'll kind of do like a shortened version because I think I'm going to probably run out of space. And then I'll kind of show like the longer way in the first one that I think kind of like makes sense. And then the last two problems I'll kind of do a shortened version. So when we're solving and graphing compound inequalities, we now have two inequalities. It's not just one single inequality that we're going to solve for. Now we have two. So we're going to have to represent both of those inequalities on our graph. So remember, this is basically two inequalities, but we've written them as one. So one of the things I think when you're first kind of understanding this is, think of this as just two inequalities with an AND. So the way we can separate it, excuse me, is put your hand over the inequality and the right-hand side of one of your inequalities, and you have -5 is less than x plus 1. So I'm going to write -5 is less than x plus 1, and then you put your hand over the other inequality and the left-hand version, and then you have x plus 1 is less than 4. X plus 1 is less than 4. Now, what you can do is you can you can solve and graph them separately and then combine their graphs at the end. And when I'm first introducing this topic, that's the way that I like to at least first explain. So it's going to take a little bit longer, and then obviously by the end, I'll show you a much quicker way to get through everything. All right. So to solve each one of these are just one-step equations. So I'm going to subtract 1 on both sides. Subtract 1, subtract 1. So therefore, I now have -6 is less than x, and x is less than 3. Now, a lot of times students have trouble using this method because we have our x on the right-hand side. So just remember, we can always rewrite that. I'll write it down below as x greater than -6. So if you have still problems with graphing when the variable's on the right-hand side, just switch them. Just make sure you also switch the inequality symbol as well. All right, so now what we're going to do is I'm going to show you how to, the AND means, they both have to include. One has to be true, and the other has to be true. So your solution set is only going to be where it's true for both of them. To get really an understanding of this, I think the best way to initially do it is graph them separately. And I even tell kids when they're taking their test, make sure you have your answer right, graph them all separately. It takes a little bit of extra time, but that's the best way for you to understand the solution. So what I'm going to do is I'm going to do 3 graphs. So I'm going to do one graph as x is greater than -6. The other graph is going to be x is less than 3. And then the last graph is going to be the solution. OK, now the only difficult thing when you're doing it with these 3 graphs is you want the table and everything to be exactly kind of the same. The numbering to basically be the same. So I'm actually going to have, let's see here. And so you want to make sure it includes -6 as well as 3. So I'm actually going to have 0 be about right here. 0, 0, 0. So let's do 1, 2, 3, 4, 5, -1, -2, -3, 4, -5, -6, -7. OK. So I'm just going to number one of them. But the numbering is going to be exactly the same. OK. So now let's go ahead and graph the first one. So the first one says x is greater than -6. So we're going to go to -6, and we're going to do a nice big open circle. Then what we're going to do is all the values that are greater than -6, well, that's going to be values that are going to the right. So I'm going to graph values going to the right. Then the next one is x is less than 3. So to go to where 3 is, again, that's going to be an open circle. And I'm going to go to all the values to the left. Now, when graphing the solution, AND means it's only going to be values that are true for both of them. So you can see at 4, for the value 4, that's true for this inequality, but it's not true for that inequality. So that's not going to be a part of the solution. You can see that the inequalities are only true between -6 and 3. So I'm going to do an open circle at -6 an open circle at 3, and I'm going to shade in the solution in between. Okay, so that's kind of the long version there. I'll do it. Yeah, I'll do it at least one more time just so you can kind of get, again, a little practice, and then we'll kind of quickly get into the next two. So again, break them apart. Cover your hand over one side, and therefore you get -3 is less than 4 minus x. Just make sure you include the conjunction and then cover up the other side, which is 4 minus x is less than or equal to 3. Now you just solve them separately. So I'm going to use my inverse operation. So I'm going to subtract 4. Therefore, I have a -7 is less than -x. Now I got to get the net x to be positive, so I'm going to divide by -1, and I obtain 7 is less than x. And here I'm going to subtract a 4. Let's use color. Subtract 4 on both sides, and what I obtain is -x is less than or equal to -1. Then I got to divide by -1. And therefore, x is now greater than or equal to +1. Just make sure I flip my signs, which I did not. Got to be careful. I made this mistake. So I keep on saying it. I just forget to do it. So make sure you always check your answer. And that's why I don't like the negative. I always, in other problems, I always try to avoid multiplying divided by negative numbers because it can make things confusing. And also, it makes it confusing when you have the variable on the right side. Because as you notice, when the variable's on the right side, you would think graphing this would go to the left. But when you switch it, you see that actually you're graphing to the right. So I always like to rewrite this. See how the inequality symbol is pointing to the x? So when you rewrite it with the x on the left, it should still be pointing to the x. So now we're going to create our 3 graphs again. Because I think the 3 graphs is just a great way to visualize what your solution is going to be. OK, now we need to make sure we have values between 1 and 7. So what I'm going to do is I'm going to have, let's say 0 be here. So we have 1, 2, 3, 4, 5, 6, 7, 8, -1. So this, let's see, that's between 3 and -6. So everything's going to be exactly the same. So again, up top, you just pick one. I'm going to graph x is less than 7. This one, I'm going to graph x is greater than or equal to 1. And over here, I'm going to graph the solution. OK, so x is less than 7. So we go to 7. Less than is going to be open. Less than is going to be all the values to the left. X is greater than 1. We're going to do an open circle at 1. And we're going to go to all the points to the right. Therefore, for our solution, you can see that the only solution where it's true for both graphs is between 1 and 7. But notice 1 is greater than or equal to, so that's going to be closed. And then it's going to be all the points in between. OK, so that's the long way to go through this. So let's go and do the last ones a little bit quicker. Now, I like setting them up separately because it's much easier, I think, to solve, and it's not as confusing. For that. However, it does bring in its own challenges because now you're graphing with a variable on the right-hand side where a lot of students will make mistakes when they're trying to flip it. However, solving like that, I think, is very beneficial for students. However, there is an easier way. You don't always have to break it apart. What you can also do is just solve it as in here, and just kind of treat these as like 2 separations. So whatever you do on one side of an inequality sign, you have to do to the other inequality. So basically, we have 3x minus 1. What we're simply going to do now is just use our inverse operations. So to undo subtracting 3, I'm going to add a 1. Therefore, I now obtain 3 is less than 3x is less than or equal to 7. Then, now I'm going to divide by 3. So you divide by 3 on both sides. And therefore, you're left with 1 is less than x, which is less than or equal to 7/3. Now, sometimes some students might have a little bit difficult, again, with the fraction. So since our number lines are integers, we're not really going to want to use fractions as our tick marks on our number line. So the best thing I like to do is either rewrite this as a mixed number, so you can see where it lies, or rewrite that as a fraction. So if I was going to rewrite that as a mixed number, that would go in there 2 and 1/3. OK? Or just type it in as a decimal, and you get 2.333. I believe. So let's go ahead now. Rather than doing 3 graphs, which is great to visualize, let's just do 1 graph. And with the and, you can see it has to go between 1 and 2. So I'm going to make sure, let's have 0 here. 1, 2, 3, 4, 5. And basically, you can see that x is greater than 1, but x is less than or equal to 2. So my values that are going to make this inequality true are between 1 and 2 1/3. So I'm going to make a nice big point at 1. And then I'm going to have to estimate where 2 1/3 is, which is going to be roughly like here. This is less than, so that's open. That's less than or equal to, so that's closed. Then the values x is in between these two values, so it's going to look like that. All right, so now let's get into the last one here. Again, we're going to use our inverse operations. So in this case, I'm going to subtract 2 on both sides. Therefore, I have a -6 is less than or equal to 4x, which is less than or equal to +2. Now I divide by 4. Oh, more fractions. Awesome. So therefore, this becomes a -3/2 less than or equal to x, which is less than or equal to 1/2. It's OK. We can go into fraction. We can use fractions. -3/2, if you were to plug that in your calculator, it'd be -1.5 or -1 1/2. So we know we're going to have some negative numbers. So let's go through. Let's kind of make this 0, 1, 2, 1, 2, 3. OK, so -3/2 is roughly going to be around here. And 1/2 is between 0 and 1, which is going to be around here. Now that's greater than or equal to, so that's solid. That's greater than or equal to, that's solid. And the solutions, x is greater than -3/2, but less than 1/2. So it's greater than and less than, so it's only going to be in there. So there you go, ladies and gentlemen. That is how you solve and graph your compound inequalities. Thanks.